Hello everybody and welcome to BeauMaths. I apologize for the long delay in between episodes. I suffered an injury that made me unable to work on this for a while, and then to boot I got sick, so it's been a bit of a rough ride, but hopefully I'll be back and kicking for a while. Last video covered the combination, addition, and subtraction of negative numbers. We used our handy pal, the number line, to get some intuition as to why these rules are the way they are. If you are a little fuzzy on that, which you very well might be considering the time between videos, I encourage you to check out part 1 on signed arithmetic. I'll link it in the description. There's no shame in rewatching a video, otherwise you might just be wasting your time with this one. Today we are going to wrap up our signed arithmetic saga with the multiplication and division of negative numbers. If you saw my pinned comment in the last video or Instagram post, yes, I have an Instagram, I'm moving the stretching of the number line to the video after this one, where we look at how all the arithmetic operations change the number line in its entirety. But today, we'll look at some more standard ways of multiplying and dividing with the number line. Alright, let's get into the lesson. So, what is multiplication? We do it a lot, but it's good to remind ourselves of what it is. Pause the video and try to explain what multiplication is. Well, there's a few good ways to explain what multiplication is. You can think of 3 times 4 as having 3 groups of 4, or the amount of squares in a rectangle with side lengths 3 and 4, but I'm going to think about multiplication in this way. Multiplication is glorified addition. 3 times 4 is the same thing as adding 3 4s together. Or equally, it's the same thing as adding 4 3s together. It doesn't matter the order you do it in. Another example is 6 times 3. It's the same thing as adding 6 3s together, or 3 6s together. Thinking of multiplication this way, I encourage you to try to figure out how we'll visualize multiplication with the number line. So recall how we did addition with the number line. We took our starting point and shifted the number of units being added in the direction the number was in. For example, 3 plus negative 4 meant we started at 3 and had to shift 4 units. We shifted 4 units to the left because of the negative sign in front of the 4. Thinking about multiplication as repeated addition, we can use what we learned about the number line in the last video for this one. Consider 2 times 4. We know this is the same thing as adding either 4 2s together or 2 4s together. Let's look at both. If we consider 2 times 4 as adding 4 2s, we want to express 2 times 4 as 2 plus 2 plus 2 plus 2. This means that we start at 2 and then shift up 2 3 more times, which is what the expression told us to do. This takes us to 8, which is what 2 times 4 equals, so we know we're on the right track. Alternatively, if we consider 2 times 4 as adding 2 4s, we take our starting point of 4 and shift up 4 units. This also takes us to 8, so the process works the same. Let's do an example. You can now choose to add either 5 3s together or add 3 5s together. I'll personally add 5 3s together. Starting at 3, we shift up by 3 units. We repeat this for each 3 we add, and this gets us to 15, which we know is 3 times 5, so we're correct. I'll leave it as an exercise to you to do it the other way, where you add 5 3s together. Your final answer should still be 15. Let's consider what happens when we multiply a positive with a negative. If I asked you to depict 2 times 6 on the number line, you could add 2 6s together by starting at 6 on the number line and then adding another 6. If I asked you to depict 2 times negative 6, how would you deal with this? Because multiplication is repeated addition, this is the same thing as adding 2 negative 6s together. If you recall from the last video, adding a negative is the same thing as shifting down by the size of the number. So 2 times negative 6 means that we start at negative 6, and then shift 6 units to the left, which takes us to negative 12. Thus, we can see that 2 times negative 6 is negative 12. This demonstrates to us that a positive times a negative is a negative. Here's an example. What's negative 3 times 5? Well, we want to add 5 negative 3s together. With the number line, we see that we start at negative 3 and then we add the remaining 4 negative 3s to it, which takes us to negative 15. What about 3 times negative 5? We will be adding 3 negative 5s together this time, and this also takes us to negative 15. What do you think the correlation between the last two examples is? We can see that both negative 3 times 5 and 3 times negative 5 equal negative 15, so they're the same thing. So it doesn't actually matter which number has the minus sign when being multiplied, the results will still be the same. The reason for this is that when we multiply a positive number with a negative, what we are doing is just multiplying the number parts. Here we multiplied 3 with 5 to get 15, and then we added the minus sign in afterwards. We can make this notion more general. Given two numbers a and b, a times negative b equals negative a times b. Just like last time, we generalize this rule so that we can see it holds true for any two numbers. For example, if a equals 3 and b equals 2, this statement tells us that 3 times negative 2 equals negative 3 times 2, which is true. So what about a negative times a negative? If I had negative 3 times negative 4, how do we interpret this? Adding negative 4 and negative 3 times? That doesn't make too much intuitive sense. Hopefully, you recall that negatives change the direction of a number, but they don't change the number size itself. Because of this, we can multiply the numbers together first and then think about the negatives. So let's multiply 3 and 4. This gives us 12. Then we can consider our minus signs. We have two minus signs left over, and we learned last time that an even number of negatives cancel out. So negative 12 becomes 12. So negative 3 times negative 4 is actually 12. We can still use the number line to represent this by looking at 3 times 4, which we could represent by adding 3/4 together. As we saw last time, this is the same thing as two changes in direction. This results in no overall change in direction, so we stay at 12 for our final answer. So we actually see that a negative times a negative is a positive number. Here's an example. We can multiply the 3 and 3 first, which is 9. Then adding in the two negatives, we see that negative 9 is 9. Two negatives multiplied together is a positive. And we can write a general expression for this by saying that, given two numbers a and b, negative a times negative b equals a times b. This is just showing us that a negative times a negative is a positive, but we are making it a general rule that holds true for any two numbers. For example, if we substitute 3 in for a and 1 in for b, we get this statement. Negative 3 times negative 1 equals 3 times 1. Both of these equal 3, so this statement is true. Ultimately, multiplying negatives follows the same pattern as combining negatives did. An even number of negatives being multiplied together is positive, and an odd number of negatives being multiplied together is negative.
With you, I can be sad with you. Just take my hand and fly up through the dreams where the skies are so clear with you.
Here's an example. Is the following product positive or negative? That would be a horrible calculation to do, but luckily all we need to know is if it's positive or negative. If we count the number of negatives in the expression, we see that there are 3 negative signs. This is an odd number of negatives, so this means that after we multiply them all together, the result is going to be negative. Something to keep note is that it doesn't matter how many positive numbers we have in there. The only thing that makes a difference about the sign of the result is how many negatives are being multiplied. This is because negative signs change direction, whereas positive signs keep the direction how it is. If you are still having trouble visualizing how multiplication on the number line works with negatives, try this. Let's say Hilda is walking down the street, and let's say her starting place is 0. And by default, she is facing the positive direction. When we multiply two numbers together, the first number is the number of steps she takes, and the second one is the length of those steps in feet. For example, 2 times 4 means Hilda takes 2 steps of length 4 feet. This takes her to a total distance of 8 feet traveled. If there is a negative in front of the first number, this means that Hilda steps backwards. So negative 2 times 4 means Hilda takes 2 steps of length 4 feet, but she steps backwards, which takes her to negative 8. This matches up with the fact that a negative times a positive is a negative. If there is a negative in front of the second number, this means that Hilda is facing the negative direction. So 2 times negative 4 means that Hilda takes 2 steps of length 4 feet. However, because she is facing the negative direction, she walks that length in the negative direction and lands at negative 8. This is the same thing as when we had negative 2 times 4 and matches up with the fact that a positive times a negative is a negative, and it fulfills that algebraic property that we saw earlier. So what about negative 2 times negative 4? This means that Hilda is facing the negative direction to start with because of the negative in front of the 4. She takes 2 steps of length 4 feet, but she walks backwards because of the negative in front of the 2. As a result, she ends up at positive 8. This is the same thing as when we just had 2 times 4. This matches up with the fact that a negative times a negative is a positive. And it fulfills the property that we saw earlier. Hopefully that's a clear way of understanding this. Once I go through the nitty-gritty of division, I'm going to make a similar analogy for that too. So hold on to your hats. Let's now move on to division on the number line. You're doing great so far. If you feel overwhelmed, maybe pause and take a break. Go outside for a bit. Take your time. This video is going to be a little longer. So what is division? See if you can summarize it. The idea of division is that we are splitting things up into equally sized groups. For example, if I have 10 friends and I want to split us up into 2 same-sized groups, I'm considering what 10 divided by 2 is. 10 divided by 2 is 5. So the way to split up 10 into 2 same-sized groups is to split it into 2 groups of 5. We can apply this understanding of division to the number line. If I wanted to visualize 10 divided by 2, I need to split up the segment from 0 to 10 into 2 same-sized parts. We can leave a mark to show the divide between these parts. The length of one of those parts is the answer to 10 divided by 2. In this case, it's 5. If I had 10 divided by 5, I need to split up the segment from 0 to 10 into 5 even parts now. After we do this, we need to look at the length of one of those parts. It doesn't matter which one since they are all the same size. The length turns out to be 2. This should be the case since 10 divided by 5 equals 2. What do you think would happen if we had negative 10 divided by 2? Well, we'd split up the segment from 0 to negative 10 into 2 even parts. The length of that part is 5, but in the negative direction, so our result is negative 5. So here we see that a negative divided by a positive is negative. How about 10 divided by negative 2? Well, we can think about 10 divided by 2, and then add in the negative afterwards like we did with multiplication. So 10 divided by 2 is 5. Then adding the negative back in, we get negative 5. So a positive divided by a negative is a negative as well. This follows from our idea of multiplication that a positive combined with a negative produces a negative. Notice that negative 10 divided by 2 and 10 divided by negative 2 had the same result. These two expressions must be equal then. We have a new rule that hopefully makes sense to you. Given two numbers a and b, negative a divided by b equals a divided by negative b. All this is saying is that it doesn't matter which number has the negative when you are dividing two numbers. It won't change the results. Like I've emphasized in the past, don't memorize the rules. Just make sure they make sense to you. They'll stick eventually if you understand them. Based on what we've done already, you might be able to guess what a negative divided by a negative number is. Let's consider negative 4 divided by negative 2. Well, we can consider 4 divided by 2 first. If we split the segment from 0 to 4 into 2 parts, we see that each part is of length 2. Then we add back in the 2 negatives which cancel out and we are left with 2, which we would have gotten in the first place if we just considered 4 divided by 2 without any of this negative sign funny business. This leads us to our last rule today. Negative a divided by negative b equals a divided by b. Essentially, if you divide a negative number by a negative number, it's the same as dividing without the negatives, because the negatives cancel out. Let's do a quick example to tie everything together. Let's solve this with a number line first. We can consider this one piece at a time. Let's first look at negative 2 times 3. This means that we add 3 negative 2's together, and this takes us down to negative 6. Now we need to consider negative 6 times negative 2. Well, we can consider 6 times 2 first. This is the same thing as adding 6 units twice, and this takes us to 12. Adding back in the 2 minus signs, we change direction twice. That's the same thing as no change at all, meaning we get 12 as the result. And finally, we have 12 divided by negative 6. We first consider 12 divided by 6, and we take the line segment from 0 to 12 and split that into 6 evenly sized parts. We see that each part has a size of 2, So adding the negative sign back in, we get to negative 2 as our final answer. Let's do this numerically without the number line now. Negative 2 times 3 is negative 6 because a negative times a positive is a negative. Negative 6 times 2 is the same thing as 6 times 2 because a negative times a negative is the same as having no negatives at all. And this, of course, is 12. And finally, we have 12 divided by negative 6, which is negative 2, because a positive divided by a negative is a negative. Similarly to multiplication on the number line, there's a really clear way to represent division on the number line. Let's consider Leonard walking this time. However, Mike is telling him how many steps he's allowed to take for a given distance. The first number is the distance, the second number is the amount of steps he can take. For example, 10 divided by 2 means that Mike wants Leonard to walk 10 feet in 2 steps. This means that the length of Leonard's steps has to be 5 feet each, so the result will be 5. If there's a negative sign on the first number, this means that the distance is in the negative direction. If we consider negative 10 divided by 2, this means that Leonard needs to get from 0 to negative 10 in 2 steps. Since Leonard has to take 2 steps forward, he has no choice but to face the negative direction so that he moves in that direction when he walks. The length of one of his steps is 5, and we put a negative sign in front of the 5 because he has to face the negative direction. So negative 10 divided by 2 is negative 5. We see this matches with the fact that a negative number divided by a positive is negative. If there's a negative sign on the second number, this means that Leonard has to walk backwards. For example, 10 divided by negative 2 means that Leonard needs to get from 0 to 10 by taking 2 steps backwards. This means that Leonard must face the negative direction so that when he steps backwards, he moves in the positive direction. The length of one of his steps is 5. We put a negative sign in front of the 5 because he has to face the negative direction. So 10 divided by 2 is negative 5. We see this matches the fact that a positive divided by a negative is negative. We also see that negative 10 divided by 2 and 10 divided by negative 2 equal negative 5, so it follows the property that we learned earlier. Finally, if there's a minus sign for both numbers being divided, this means that Leonard must walk from 0 to negative 10, and has to do it by taking 2 steps backwards. Leonard can achieve this by facing the positive direction and walking backwards. The length of one step is going to be 5, and since he's facing the positive direction, our resulting number is also going to be positive. We see that this matches with the fact that a negative divided by a negative is a positive. We also see that this is the same result as when we had a positive divided by a positive. Hopefully that's a fairly clear visualization of division on the number line. It looks like Mike's cruel and unusual punishments for Leonard have their advantages. Well, that just about sums things up for today's video. Today we learned how to multiply and divide using the number line. Multiplying and dividing a negative with a positive produces a negative. Multiplying and dividing a negative with a negative produces a positive. Just like with the combination of minus signs, an even number of negatives multiplied or divided produces a positive number. And just like with the combination of minus signs, an odd number of negatives multiplied or divided produces a negative number. Well, we did it. We're through with the review of signed arithmetic. I hope you all enjoyed it and found it useful and worth your time. With time and practice, these rules will be as natural as breathing to you. If you weren't super comfortable now, that's okay. You'll be using these concepts a countless number of times, so there's plenty of room for practice. And as with last video for practice, just make up whatever expression you'd like using negative signs in any combination you'd like. Next time, we're gonna look at how operations manipulate the number line. And I swear on Leonard's paycheck, it's actually going to be the next one. But until then, have a good one, stay groovy, and I'll see you in the next video.